So, I am ready to the last 45 minutes of new information in this course. We need to do all the generalizations that I promised in the beginning. Not only talking about one proportion. We spent all the first half of today speaking about one proportion. Now we'll go on to two, several, and multi-categorical proportions, if you like. So we do all that in 45 minutes and some bit more talking about R. So let's get started. Two proportions. What if we want to compare males and females in how they vote in a president election, for instance? Well, here is first of all a confidence interval method for the difference between two proportions. We've seen difference between means early on. Here is the difference between two proportions. We need the statistical uncertainty, the sampling error for us, a difference between two proportions, and we need some distribution where we use the normal distribution today to do such confidence intervals, and the standard deviation of the difference between two binomial proportions is the root of the sum of the two variances. We've seen similar reasonings early on, so let's not dwell on the details now. There is a slightly different rule of thumb to make this a valid approach, but it's still the same. The ends should be sufficiently large for this approximation to be valid. That's the confidence interval. Here is the first version of a hypothesis test for a situation like this. This is one of the few cases, maybe the only one actually, where you will see explicitly two different methods for exactly the same situation. There is a reason, but let's begin with this one. We could have the idea to make a hypothesis test where we compare two proportions with each other. Are the Macron proportion the same for males as for females, for instance? That could be one question one could put oneself. It could also be the survival of some disease or the benefit of some treatment. How many survives the treatment? Would that depend on your gender? Would that depend on whether you're young or old? All sorts of proportion comparisons could come up relevant. The first test statistic is based on the normal distribution. One thing we will do a number of times in the next 20 minutes is that we will, when we have such a two-group situation, we might compute what we could call the joint percentage, or the average percentage, or the overall percentage of success. That is, we count the number of successes across the two samples, across the two groups, and we divide by the total number of observations in the two groups. If there should be one proportion that should be valid in a way for both populations. Can you, are there some guys who want to come in, or are they just waving at me? No, now they were running away. So anyway, don't wave at me. Then, if there should be one that goes for both populations, this would be it, right? The best guess of a joint P, of a common P, would be this one. We use this common P, or the best version of one common P among the two that could be there. So when we compare, of course, the test statistic makes sense to compare the two proportions with each other. We want to compare, so we subtract them from each other. And then I divide by some statistical uncertainty that comes from this joint P. So it's kind of a binomial standard deviation coming from this joint. You don't have to, we don't prove all the formulas now. This is the right statistical noise measure to use here. And then we have a standard normal, and we can do usual p-values as we've seen a number of times. So that's a straightforward method for this. I'm not going to exemplify this, but here we're going to take some steps towards exemplifying it, and then we'll take another step. Here's another example. classic clinical type example where there are two populations, in this case females, some that use, very old data, some that use birth control pills and some that do not use birth control pills. Then a certain disease is investigated. Either you get the disease or you don't. In this case, blood clot or not. So we want to compare the health risk or the risk for that particular illness between those two groups of people. We want to compare those percentages. We want to compare those risks. Now, before we actually do some statistical testing of those two proportions, let's compute the proportions that this is all about. Namely, that we have 57 people in one sample from one population, and we have 167 persons sampled in the other population. And then, what is the risk of actually getting the disease among the birth control group? That's around 40%. What is the risk of getting the same disease in the other group? It's only 21%, right? These are the two risks, as we could call them here, but generically, it's two proportions that we want to compare. And the common estimate, the common risk across the two groups, if we should give a joint one, I count all the occurrences of the illness and divide by the total number of people, right? Which would then be somewhere in between, with highest weight to the group with the highest number of people, of course. So it's not right in the middle, 26%. Now, instead of actually exemplifying the test that I showed you, I will go to the next step of being able to compare more than two proportions, and then the tool that I will give you will also be able to compare two proportions. And that's a more general tool. It can compare many proportions, including only two. But we have our game to make sure that we... Let's see if Macron is still up for it. This is difficult. I found the music again. Oh, that's nice. Like that. Well, it's getting better. Your gut feeling is, it helped with a bit of music there. Good. This is pure speculation on my side. This is not because I know anything or I didn't check, but I just thought probably females like this Macron guy, right? And anyway, his female teacher liked him. Have you seen the story? He's married to the teacher he had as a 15-year-old. That's pretty nicely done, right, guys? Actually, scoring the teacher you have as a 15-year-old? Who wouldn't dream of that at that time? And anyway, let's sorry. Yeah. 65%, 55%, that's really significant, I assure you. You can check later on if you want.